So, in the last lecture we discussed the Shakun et al. Paper, which looked at data from 80 different ice core and ocean cores to develop a global mean temperature from proxy data and showed how it changed from the last glacial maximum to today. Okay. And we also saw that when we compare the model simulation by NCAR model with proxy data, there were some differences, and these differences were there because the proxy data does not sample the whole globe. Okay. It only samples a part of the region. So, some errors introduced of the order of half to 1 degree. Okay. Now, this is shown in this graph where the proxy data of Marquardt et al. Was compared with the model data, which used either the annual mean temperature or the seasonal mean temperature according to the proxies. And you see there is a difference between annual mean and seasonal mean temperature, and if you use seasonal mean, the model is closer to the observation. So, that shows that the proxy data does not necessarily sample the annual mean. Now, we go back to the original paper of Shakun, and we see that the Arctic started warming around 18,000 years ago, that is the red line, and that Arctic warming immediately caused the CO2 to increase, and the CO2 increase was exactly following the temperature increase in Antarctica, but the global mean temperature lagged by around 800 years. Okay. And this because of the CO2 increase due to the increase in Antarctic temperature, that CO2 spread all over the globe, because CO2 gets well mixed in the atmosphere, and that caused warming of the northern hemisphere, but it will not occur immediately because the oceans have a large thermal inertia. They take a long time to respond to the greenhouse effect of CO2, and that takes about around 800 years. Okay. So, in the bottom graph they are shown a distribution function of the global mean temperature, the northern hemisphere temperature and the southern hemisphere temperature. Okay. And you can see that the southern hemisphere temperature warming occurs earlier because Antarctic warmed earlier, the northern hemisphere warmed later, about 700 years later. So, when you calculate the global mean temperature warms around 500 years after the warming of the southern hemisphere. So, this is an important conclusion which shows clearly that the warming that occurred from 18,000 years ago to present was on account of the increase in carbon dioxide coming out of the ocean, a greenhouse effect on earth, which caused that warming about 5 degrees centigrade. So, this clearly proves that increase in CO2 causes global warming, because a lot of people had doubts whether CO2 causes global warming or global warming causes CO2 increase. This paper has clearly demonstrated that CO2 warming occurred first in the past and the global mean followed. So, that means the CO2 increase which has occurred in the last 100 years will continue to cause warming of the earth for the next 1000 years. Okay. That is the message from this paper. Okay. Now, the advantage of doing simulation is you can look at how the spatial pattern of simulation from the last glacial maximum to today. You see this graph showing the cooling that occurred during the last glacial maximum. The highest cooling was of course near Greenland and Arctic. But suppose you use only CO2 changes, you will not see much cooling. Okay. CO2 would have decreased in LGM, but it would have caused maybe 1 degree of cooling, not 20 degrees. If you include dust, which increased during the glacial maximum, there is some cooling, you can see that. If you include vegetation, because vegetation changes when climate changes, you see some effect, but only when you include ice sheet, you get the maximum cooling. Okay. When you add all these 4, you see the maximum cooling here. Okay. So, this shows clearly that to reproduce the spatial pattern of warming all over the globe during large glacial maximum, you have to include ice sheet to reproduce the Arctic cooling, but you have to include also all the other forcing to correctly reproduce the changes in temperature, spatial pattern. Okay. Now, this is the same graph I showed last time, comparing the fact that the northern hemisphere warmed much later than the southern hemisphere. Okay. So, there is another example showing that carbon dioxide changes occurred earlier than temperature changes. Okay. There is a different data set here, okay, and they are able to show clearly that carbon dioxide started increasing 500 years before the global mean temperature. This is again the same graph from Shekhar et al. In a simplified format, showing Antarctic temperature increased first, CO2 followed it, and this was followed by global mean temperature. And here is an example showing how the greenhouse gases changed. There is a change in CO2, change in methane, change in nitrous oxide, all greenhouse gases. But note that the biggest change was CO2. Methane and nitrous oxide changed, their impact on radiative forcing was about 0.5 watts per meter squared. Well, CO2, which increased from LGM to today, contributed to 2.5 watts per meter squared. So, CO2 is the dominant gas, but of course, methane and nitrous oxide add. That is why when you take CO2 and add these two, you get much higher radiative forcing, and that radiative forcing was what led to this warming of the global temperature. Okay. So, you can explain the change in global mean temperature when you include both the changes in ice sheet and changes in the greenhouse gases over the last 20,000 years. Okay. Now, there are other papers which have reproduced this result, and they have taken some sort of different ice cores. One is in Baird, one is Triple Dome, and so on, and they show that in this case CO2 changes occur earlier by about 180 years in one location, that is Triple Dome, and the other it occurs at 169, changes which are somewhat different, they are not identical. Okay. So, you must remember that when you take data from various sources, there will be some differences, because we are depending on proxy data, it has its own conversion factor. Now, one interesting thing I want to highlight is the fact that methane changes are much larger than change in CO2. Okay. You look at the last, as you came to the last glacial age, you saw sharp change in methane, but carbon dioxide change is not that much. Okay. Same thing during the Younger Dryas event, the methane dropped dramatically, but not CO2. So, you must remember that carbon dioxide and methane come from different places. Methane comes from land, that is large places where you have water in land, okay, and where methane is generated in these water bodies. Like today we have methane generation in rice fields. Similarly, in the past, when out of the ice melted, the large areas covered with water, there was generation of methane. Okay. So, methane responds very rapidly to temperature change, because methane is produced over land where water is present. Okay. So, you must remember that methane and CO2 sources are different. Methane has biological sources, CO2 does not have that many biological sources. Now, in this last graph here, comparing the last 10,000 years from the LGM to 11,000 years ago, we are comparing data from Greenland and GRIP and data from Antarctica. I am showing this result to highlight the fact that changes in the northern hemisphere is much more dramatic than in the southern hemisphere, because northern hemisphere contains land, southern hemisphere is mainly ocean. So, changes in southern hemisphere are much smoother than the changes in northern hemisphere, and so this must be kept in mind. The dramatic changes you saw during younger dryas is not seen in Antarctica. It responds, but much more subdued fashion, smooth fashion. So, this must be kept in mind. Okay. So, the Atlantic meridional ocean circulation changes associated with orbitally induced retreat of the northern hemisphere ice sheet is the most plausible explanation for the early southern hemisphere deglacial warming. Okay. So, the warming we saw in Antarctica can only be explained because the AMOC suddenly stopped because of the Heinrich event in the northern hemisphere, and when AMOC stopped, lot of heat was kept in the southern hemisphere and hence it warmed rapidly. That warming led to an increase in CO2 in the whole globe. Okay. So, you must remember the complex interaction between changes in ocean circulation induced by AMOC, increase in CO2 in the southern hemisphere, and finally the global mean temperature change. So, they are all linked in a very complex way, and Shagun et al. Paper was able to decipher this complex interaction by looking at both proxy data as well as model simulation. Okay. Now, we can briefly look at what is the radiative forcing caused by ice, by CO2 and land albedo due to land ice. You can see that CO2 is a dominant contribution, minus 1.28 watts per meter square cooling occurred because CO2 declined. Okay. The land albedo contribution is there, but it is not as high as CO2. Okay. So, between albedo and greenhouse effect is more important according to this data from Manabe. Okay. Now, dust also made a contribution, because during the last glacial maximum vegetation got reduced. So, deserts increased both in India and in Africa. Okay. Sand dunes spread all over the place. So, in the simulation we include only ice sheet and greenhouse gases, you may not get the full answer. Okay. So, you have to look at dust also. So, in this particular estimation, dust contributes minus 2.8, sorry, minus 1.4, GHG is still dominant at 2.8, ice sheet contributes minus 3 and vegetation minus 1.2, and the total is minus 8.4 at LGM. So, LGM had large cooling because of greenhouse gases, dust reflecting the solar radiation, ice sheet reflecting solar radiation, and vegetation also changing the albedo of the earth. Now, we will continue the discussion now about what happened during the last 6,000 years based on an hypothesis by Professor Rudiman. Now, this is a very interesting hypothesis. Rudiman has written a book called Plows, Plagues and Petroleum. What does he mean by that? He means plows means conversion of forests into agricultural land, which changed albedo as well as caused more methane to come from rice fields. Plagues is when large number of human population decline because of pandemics, and once human population declined, the agricultural land went back to forest. Okay? And finally, of course, the discovery of petroleum 150 years ago, of course, caused a dramatic change in global temperature. So, Rudiman talks about how humans took control of global climate gradually, starting from deforestation, rice cultivation, and finally to petroleum. Okay? Now, Rudiman's hypothesis is that the global mean temperature should have declined from 8,000 years before present to today, this period, because that is what happened in the previous interglacial events. In the previous interglacial events, when the solar radiation started declining, then the temperature declined, but on earth it has not happened, it has remained constant. So, this is a puzzle, and Rudiman claims that this constant temperature that we enjoyed during the last 10,000 years due to human interaction. Okay. Let us see what is this hypothesis. Okay. Now, what Rudiman does is he compares the deglaciation that occurred many times during the last 800,000 years. The last 800,000 years, he has identified 8 deglacial events. Okay. He compares them all with the last interglacial, we started 17,000 years ago. Okay. So, here is one comparison he has made. The red line is the period from 10,000 years before present to the present, while the black line is 78,000 years ago to 77,000 years ago. Two 10,000 year period separated by around 770,000 years. Okay. So, what is happening in the previous period where human beings were not there was that once the solar radiation started declining, the CO2 started declining, okay, from 260 to 240. Now, that did not happen in this interglacial. In the present Holocene, you see from around 6,000 years ago to present, CO2 increased from 260 to 280. Most people assume that this change is natural, okay, but Professor Rudiman disagrees. He thinks this change is because of human practice of agriculture that change both the albedo of the land as well as the release of methane from rice fields. Okay. Here is another example he has shown here, comparing all the previous interglacial. There is a blue line, okay, two different ways of doing it, and the change in methane in the last 10,000 years and change in CO2 both do not follow what happened in the previous 8 interglacials. Okay. So, this is very interesting result where you are saying that the last 6,000 years is peculiar because it does not follow the previous 8 interglacial events, where when the radiation started declining, the amount of methane and amount of also CO2 declined, because CO2 and methane are linked to temperature. Okay. So, his point is that the fact that the present interglacial from 6000 to present, the changes in methane and CO2 are different from the previous 8 interglacial, implies that human beings have played some role. So, this is the argument. He is saying that we should have been going along this line from 5000 years ago to the present. The methane should have gone down from 550 parts per billion to 400 parts per billion. Instead of that, it increased to 700 parts per billion. Okay. Same thing with CO2. According to him, CO2 should have declined to around 245 parts per billion, but it increased to 280. So, he claims that this increase in methane and CO2 in the last 5000 years is human induced. Now, this is the area that Rudiman looks at from papers by Fuller and Larson, areas where agriculture cultivation started. The areas marked yellow were the time when cultivation started around 8000 to 12,000 years ago, and the areas marked green were the areas where cultivation started from 4000 to 8000 years ago. Okay. You can see that China and the Middle East and South America started earlier, and Africa, India and America, the cultivation, domestication occurred later. Now, here Rudiman has estimated rice production and its contribution to methane. So, he estimates rice production areas has increased from 1000 square per kilometer to almost no to 300 kilometers squared. Okay. And that increased methane by 70 parts per billion. That is his estimate. Okay. Actually, increase is around 100 parts. So, Rudiman argues that the increase in rice cultivation in India and China contribute to increase in methane. And he also is able to locate when in these old civilizations, when livestock, that is cow and sheep and other livestock, were domesticated. Okay. And remember, these livestock emit methane, remember that. So, he is looking at years 5000 years ago to 3000 years ago to 10,000 years ago, the discovery of livestock in fossils. Okay. So, the point that Rudiman is making is that the amount of radiation coming from 10,000 years ago to 1000 years ago, the decline in solar radiation was around 50 watts per meter squared in the present interglaciation, while in the earlier interglaciation it was around 70 watts per meter squared, slightly higher. Okay. So, I would argue that maybe that higher decline in solar radiation may have contributed to the reappearance of glaciers in the past, but in the present the decline was less, so it may not have happened. But Rudiman would not agree, he would say no. So, he compares the amount of methane in ice core with solar radiation. You can see there are differences. In some periods, the methane change agrees with solar radiation, but in others it does not. Okay. So, this summary of what I said about Neolithic settlements which changed the emission of methane in the past. So, this is a point about rudiment, that if methane had not increased in the last 5,000 years, the decreased solar radiation would have triggered the next ice age. So, he says the next ice age was averted because methane increased from around 400 parts per billion to 700 parts per billion. Now, here again he is comparing methane variation in the past 10,000 years to the previous interglaciation. There is a big difference, okay, both in methane and CO2. So, here is a point that the increase in CO2 and methane in the last 5,000 years is probably human induced. And he has compared all these examples with the last interglacial. In all previous interglacials the methane declined, but the present one it has increased. Okay. So, he is comparing this with the previous interglacial. And he relates it to the civilization of the late Stone Age, Bronze Age and Iron Age, where they started cultivating crops. So, that is his major claim. And here he is showing it in terms of methane concentration, and so similar to the last figure really. So, evidence of growing Arctic zone methane in the past 5,000 years comes from differences between the amount of methane trapped in the Arctic versus the amount sealed in Greenland. So, the amount of methane in Greenland Arctic are not same, okay, because northern hemisphere there is a lot of permafrost in land regions. So, the methane concentration is higher by about 5 to 10% compared to Antarctic. Okay. So, that all he talks about. So, this is a claim that rice cultivation contributes to methane. Okay. Then he looks at all the sources of methane, both through agriculture and through other sources. Of course, now these days fossil fuels dominate. Okay. And so, his argument is that if CO2 had naturally changed, it had gone down in the last 6,000 years, would have contributed to the new ice age. So, he is trying to explain what are the differences between what should have happened to what has happened in terms of CO2. So, here is a summary of the role CO2 and albedo played in the last glacial maximum. Okay. So, Rudiment says his calculation shows that human activities have increased the CO2 concentration by around 40 ppm. Okay. But there are other people who do not agree that this large increase would have happened. Okay. He plays a role for clearing the forest. And then the other remark he makes about the role of pandemics. He has historical data on how pandemics occurred in Europe and in China. Okay. And whenever the pandemic occurred, he claims CO2 was lower. Here also declined. The CO2 decline in the last 2000 years, Rudiment attributes the pandemic. This is a bit controversial because both the CO2 data and the data on pandemics are not as accurate as we would like to have. Okay. So, he tries to relate the decline in CO2 to pandemics, which I am not sure is that reliable. So, with that I conclude the discussion on the Holocene based on Rudiment's hypothesis. It is an interesting hypothesis, but we cannot be too sure that this actually happened. We need more data both on the human removal of forest and cultivation of rice to be convinced the human being began to influence the global climate 5,000 years ago. In IPCC, 1850 is considered as pre-industrial, where human impact on climate is small. So, all the discussion is about 1850 onwards. Okay. all the global negotiation is to compare global mean temperature with 1850. But if you believe in Rudiman, human impact started 5,000 years earlier. Okay. But this is not proven yet. We will need more data to verify whether human beings really had an impact on global climate. In the next lecture, we will look at an unusual event in the past called the snowball Earth, where the entire Earth was covered with ice. It is a unique time period well before human beings came, which we will look at in the next lecture.